Hello, 7th graders. Let's talk about lesson 113 today. We're going to be focusing on the volume of pyramids, cones, and spheres. So what I've done is I've drawn a pyramid for you here just so we can go over some terminology. So a pyramid is a geometric solid. So in other words, it's three-dimensional. It takes up space with one face that is a polygon, and it's called the base. So the base would be this rectangle at the bottom of the pyramid. So a pyramid has a base. It has other faces that are triangles. So we have these faces. There are four of those that would go around. Those are called lateral faces. They also have a common vertex. This would be this point up top. And one thing to note about the vertex cannot be in the plane of the base. So you think of that flat edge of the base, make that into a plane that extends in all directions. That vertex cannot be laying in the plane of the base. That just means that it has some height, which makes it three-dimensional. Also, worthy of note, where two of these lateral faces meet, we come up with a lateral edge on the pyramid. So we have four lateral edges that go around the top. So we have the vertex, the point at the top, the face, okay, those would be the triangles that go around the side. We have the base, that polygon at the bottom, and then our lateral edge where our faces meet. Okay, I've just added something else to our pyramid here, and this would be a segment that joins the vertex to the center of the base. That is called the axis of the pyramid. So think of just that imaginary line from the vertex to the center of the base. Now, when we talk about the altitude of a pyramid, this is going to be the perpendicular segment from the vertex to the base. And luckily in our book, we are going to focus on just the right pyramids where that axis is also the altitude. So we're forming a right angle from that vertex down to the base. So that's going to give us the altitude, or what we would call the height of this pyramid. This height is going to be instrumental in finding the volume of this pyramid. Okay, now I've added a cone in here. I obviously did not draw this cone. This cone is like a pyramid, except that the base here is a closed curve instead of a polygon. Okay, so our lateral surface then is going to be a curved surface. So we're talking about this curve that goes around the outside here. And that lateral surface extends between the vertex and this circular base down here. The axis is still the same, so we have the vertex up at the top that comes down to the center of the base. And in this book, we are going to just focus on these right cones where that axis would form a right angle when it hits the base. So this axis is also going to be what we call the height. So I have an H here, which would also be considered the altitude of this cone. Okay, so a cone is classified according to the shape of its base. So this would be a right circular cone since the base is a circle. We also have something called the slant height. So this is the distance from the vertex to any point of the circle that forms the base. So the slant height would be this distance on the outside, or this distance, or this distance. Okay, so we're looking at the outside. We don't really use the slant height that much, except for you might have seen that we have a right triangle that was formed using that slant height. So the slant height, the distance from the vertex to any point of the circle that forms the base. And this slant height is really only defined for the right circular cones, because otherwise, if it weren't a right circular cone, the slant height could be shorter on one side and longer on the other. So we really only define that for the right circular cones. So when we talk about finding the volume of pyramids and cones, what we're going to do is we're going to take 1/3 the area of the base times the height. So in other words, the area of the base times the height divided by 3. Or I wrote it out this way, 1/3, that capital B is area of the base times the height. So this says find the volume of the right rectangular pyramid. Okay, so couple of things. 1/3, so I know that I'm going to have 1/3 of something. Area of the base. Well, the base in here is a rectangle at the bottom. The area of that rectangle would be length times width, so 9 times 7, which would be 63. And then we're going to multiply by the height. Okay, so the height of this figure would be 8. Okay, so that's all I have to do to figure this out. So let's do the multiplication. So this could be over 1 over 1. I can do some canceling here. My 3 would become a 1. My 63 would become a 21. So now I just have 21 times 8. So 1 times 8 is 8. 2 times 8 is 16. So I come up with 168. Now, this is volume. So we know that volume is measured in cubic units. So we had inches, so it would be inches cubed. So 168 inches cubed. Okay? The same thing goes for finding the area of a cone. We're going to do 1/3 the area of the base times the height. Now, since this is a circular cone, okay, the area of that base is pi r squared, because that's how I find the area of a circle. So 1/3 pi r squared times the height. So let's go ahead and figure this out. So a right circular cone has a base of radius 6 feet, so my radius is 6, and a height of 8. Find the volume. Okay, 1/3 pi r squared, so pi 3.14 times the radius squared. Well, the radius is 6, so square that, 36. And then multiply by the height. The height is 8. Okay, so I'm just going to put those all over 1. I'm going to do a little bit of canceling before I do some multiplication. So I can do my 3 and 36. That'll become a 1, and that will become a 12. Okay, so let's go ahead and do 12 times 8. We know that 12 times 8 is 96. So we'll do 3.14 times 96. So 4 times 6 is 24. 6 times 1 plus 2. 6 times 3. Bring down my 0. 9 times 4 is 36. Carry a 3. 9 times 1 plus 3 is 12. Carry a 1. 9 times 3 plus 1 is 28. Let's add those up. 4, 4, carry a 1. 11, 10, and 3. Now let's put in our decimal. So 2 spaces and 2 spaces. So I come up with 301.44. The units we were using was feet. So feet, because it's volume, cubed. And there's my answer. All right, let's talk about the sphere then. So we know that the sphere is a perfectly round 3-dimensional shape, and all the points on the surface of the sphere are the same distance from the center. So we have this sphere. The center of that sphere to any point on the outside of the sphere is called the radius of that sphere. And all of those points on the surface of the sphere are the same distance from the center. The way that we're going to find the volume of a sphere is take 4/3 times pi times the radius cubed. So here's an example. A ball with a diameter of 20 centimeters has a volume of how many cubic centimeters? Round your answer to the nearest 100 cubic centimeters. Okay, let's go back to our diagram that we just had with the last page here. And we'll use this for our ball. So it says that the ball has a diameter of 20 centimeters. So we would know that the diameter would span all the way across. So if the diameter is 20 centimeters, the radius then is going to be 10 centimeters. So the radius is going to equal 10 centimeters. So we need to find the volume. So remember, we're going to take 4/3 pi r cubed. Okay, so we're going to take 4 over 3 times 3.14 for pi. Okay, so 3.14 for pi, and then times the radius cubed. So we know that the radius is 10, so 10 cubed is 1,000. Okay, so let's go ahead and take our 3.14 times 1,000. So I know when I multiply by 1,000, I move the decimal point 3 spaces to the right. So 1, 2, 3 would give me 3,140, and that was just multiplying these two. So I still need to take 4/3 of that. So over 1 times 4 over 3. Okay, so let's take our 3,140 times 4. So I get a 0. 4 times 4 is 16. Carry my 1. 4 times 1 plus 1 is 5. 4 times 3 is 12. So I have 12,560. I still need to divide that by 3. So 12,560 divided by 3. 3 goes into 12 4 times. Subtract and get 0. Bring down my 5. 3 goes into 5 1 time. Subtract 2. Bring down my 6. 3 goes into 26 8 times. 8 times 3 is 24. Subtract. Bring down my 0. 3 goes into 20 6 times. 6 times 3, 18. Subtract. I still have 2 left. Okay, so this is the thing though. If we go back to the problem, it says round your answer to the nearest 100 cubic centimeters. So I just need to round this to the nearest 100. So it's either going to be 4,100 or 4,200. So, oh, sorry, my dog's going to help. It's going to be 4,200. So 4,200. We were looking at centimeters, Roman. We were looking at centimeters, so it would be centimeters cubed. Okay, not only is he helping, he's chewing pencils also. So, enjoy working on this lesson.